Okay, here's how we do this. Let's remember that we're looking at this equation to find pH from the concentration of H+. And if we don't know H+, but we do know OH-, we're going to use this equation where H+ is equal to Kw over OH-, and Kw is a constant that is always equal to 1 times 10 to the negative 14th. Also remember that the log button is right here on your Texas Instruments calculator. It is next to the number 7. All right. So here we go. What's the pH of a solution if the H+ is 6.35 times 10 to the negative 6th? pH is equal to negative log, in this case, 6.35 times 10 to the negative 6. Let's bust out our calculator. So negative log of 6.35 times 10 to the negative 6th. Our pH is 5.197. Let's round that up to 5.2. Okay? Here's number 2. It doesn't give us H+, it gives us OH-. So the first thing that we want to do is solve for H+. So it's going to be equal to Kw over OH-, which we know, both of these. Kw is 1 times 10 to the negative 14th. OH- is 7.15 times 10 to the negative 10th, and let's plug that in. 1 times 10 to the negative 14th divided by 7.15 times 10 to the negative 10th gives us a H+ of 1.398 times 10 to the negative 5th. I'm going to round that up to 1.4 times 10 to the negative 5th. We'll plug that right into our equation, where pH is equal to negative log, in this case, of 1.4 times 10 to the negative 5th. Now I'm going to try something fancy here. Because we got 1.4 times 10 to the negative 5th as our answer, let's use our calculator's answer function. That's this guy right down here. Answer function is right here on the bottom. It's the shift function of the negative button right next to the enter button. Watch what happens. We'll say negative log. I'm going to say second answer, and what that is doing is taking the answer from the previous problem, so I don't have to enter it again, and our pH is 4.85. Okay, you guys getting the hang of it? Okay, this is the answer key to 15b, how to calculate pH from concentration of H+. We're going to be using these two equations. pH is equal to negative log of H+. And if you don't know H+, but you do know OH-, here is how to find H+ using Kw, which is a constant, 1 times 10 to the negative 14th. Let's remember that the log button on your calculator is right here next to the 7. Okay? So here we go. This one we already know H+, 6.35 times 10 to the negative 6th. So let's plug it into our equation. pH is equal to negative log. In this case, it is 6.35 times 10 to the negative 6th. I'm going to bang it right into our calculator. Negative log of 6.35, 0.35 times 10 to the negative 6. And our pH is 5.197. Let's round that to 5.2. All right. Number 2, a little trickier because it gives us OH-, but we know exactly how to solve for H+. It's equal to Kw over OH minus, and you know both of these. Kw is a constant, 1 times 10 to the negative 14th. OH minus is what they gave us, 7.15 times 10 to the negative 10th. Let's plug it in. We're going to have 1 times 10 to the negative 14th. Whoops, didn't take the shift button. 1 times 10 to the negative 14th divided by 7.15 times 10 to the negative 10th is 1.398 times 10 to the negative 5. I'm going to round that up to 1.4 times 10 to the negative 5. Now, when I go to plug it into my equation for pH, it's equal to negative log of the H plus. There's a trick on your calculator that you don't need to actually enter this number twice, because your calculator has got something called an answer function. That's this guy right here. You see this catalog here, we see I here, and we see this negative button here. Well, we want this answer function, and it's blue, so it means we're going to shift to get to that. So I'll show you how this works. Okay. So on your calculator, you just found the answer from the previous problem, and we're going to use it in the next step. We're going to say negative log. Now we're going to shift and hit answer, and that's going to use the answer from the previous step that we just did, 4.854. Let's call that 4.85, and if you round that up to 4.9, I won't get too bent out of shape. All right, here's number 3. What's the pH of a solution if the H plus is 2.9 times 10 to the negative 3rd molar? pH is equal to negative log of H plus. It tells you that right in the formula. Coda's talking to me. Hi, buddy. I'm doing a video here. Shush. H plus, we know, is 2.9 times 10 to the negative 3rd molar. Let's plug it right into our calculator. So we're going to say negative log. Coda just knocked something off of my desk. He's being a jerk. 2.9 times 10 to the negative times 10 to the negative 3rd is 2.537. Let's just call that 2.5. Okay. Number 4, it gives us the concentration of sodium hydroxide, but we don't know what the concentration of OH minus is. What that means is that we're going to need to dissociate this. Well, you know how to do this. 6.8 times 10 to the negative 4 molar sodium hydroxide. Coda, quit it. Is going to dissociate into sodium hydroxide, 6.8 times 10 to the negative 4th, and hydroxide, 6.8. Trying to write an 8 here, ladies and gentlemen, times 10 to the negative 4th. That's going to go right into our equation to solve for H plus, because we don't know H plus, we know OH minus. So this is getting to be pretty standard fare here. 1 times 10 to the negative 14th divided by 6.8 times 10 to the negative 4th. And we'll plug this into our calculator and then use the answer in the next step. So we're going to say 1 times 10 to the negative 14th divided by 6.8 times 10 to the negative 4th. I get 1.47 times 10 to the minus 11th. Let's round that up to 1.5 times 10 to the minus 11th. We're going to use this right in the next equation to find pH. So negative log of our answer, 1.5 times 10 to the minus 11th. So let's say negative log of our answer, 10.83. Okay. All right, last one, ladies and gentlemen. This is an acid H2CO3. It dissociates into 2 H pluses and 1 carbonate. So when this dissociates, 7.5 times 10 to the negative 4 molar, we'll get twice as much. Just got an email from Pearson. Twice as much H plus. Now, if you're having a hard time with this, take 7.5 and multiply it by 2, and you get 15 times 10 to the negative 4. Or, if we're going to write it in proper scientific notation, 1.5 times 10 to the negative 3. Doesn't matter how you write it, either one of these will give you the same answer. We're not worried about the carbonate, but it is the same as our original concentration, so that stays just like this. All right. Anyway, this is what we want, our concentration of hydroxide, and the pH is going to go right into our calculator, negative log of 1.5 times 10 to the negative 3rd molar. Here is our fancy schmancy calculator. Negative, let's clear this so you can see what I'm doing. Negative log of 1.5 times 10 to the negative 3rd. And there, ladies and gentlemen, is our pH, 2.82. If you just want to round it to 2.8, that's fine. Okay, easy peasy. See you later.